right, I'm going to go ahead and explain the homework from last night. Remember that you have to have a periodic table in order to do this. And if you have mistakes, I want you to correct them, okay? So if you don't yet have this memorized, write down what I'm going to ask you to write down. And I know that we did 1 and 3 together in class yesterday. So remember, the atomic number is the number of protons. The mass number is the protons plus the neutrons, not according to what the atomic mass is on the periodic table, but what is in the picture in terms of the protons and the neutrons. So remember, we labeled the dark dots as the neutrons, the negative symbols as the electrons, and the positive ones are our protons. So we wrote down, and I'll just go over this one quickly because we did it yesterday in class. Our atomic number is the number of protons, so there's 1. So you should have a positive 1 there. The neutrons are the dark dots. So when we add together the protons and the neutrons, we get the 1, 2, 3, 4, 5, 6. 6 is our mass number. And then, Randy, we identify the element based on the atomic number, okay? So our element name, because we have 1 proton and the atomic number or the atomic element that has a 1 as its atomic number is hydrogen. So that element that we're naming then is hydrogen. Okay, now I want to go through a couple things with you just real quickly that we haven't done yet. Typically, I tell you, assume that the protons and electrons are equal and the atom's neutral. Occasionally, they're not going to be. So, Keegan, how many protons do we have in this diagram? Nope, the positives. 1. And then, Keegan, how many electrons? How many negatives?
4.
Oh, yeah. I'm sorry, I didn't even notice that one. You're right. There's 1 right there. So 1, 2, 3, 4. Okay, so 1, 2, 3, 4. I'm going to have you guys write that down. So sometimes atoms are charged. They have a charge to them because the number of protons and electrons are not equal. So these will cancel each other out, but then we have 3 extra negatives. So how we would write this is hydrogen. Hello? I do. Sure. Bye-bye. Peyton, Mrs. Firmoil needs to see you. Okay. So we're going to put hydrogen, and then how we write this as a charged atom, when we're putting the charge on it, we write a little -3 in the upper right-hand corner. That's called a superscript. If we were to write a number lower, like down here, that's a subscript. But when we're writing the charge on an atom, we write it as a superscript. We write it slightly above. So this is what we call, and I'm going to go ahead and write this up here, and I want you to add it to your notes. An ion is a charged atom, and this happens when the proton number is not equal to the electron number. So you have more positives than you do negatives, or you have more negatives than you do positives. Now, I did not give this one to you as a vocab word because it was not in your book and you would not have been able to define it. But I would like you to know this term, and I'm giving it to you now. When you're just looking at the periodic table, you're going to assume that your protons and electrons are equal, but there are times when the electron numbers can change. If an atom gives away electrons, it'll be positive. If it steals electrons from another atom, it'll be negative. And we're going to talk about this more and more later. Now, contrast this to that term we've already learned, which was isotope. Isotope, remember, are forms, and go ahead and write this down, of an element, okay, with different neutron numbers. So if we change the numbers of electrons, we get an ion. If we change the number of neutrons, we get an isotope. So again, an ion is a charged atom where the proton number and the electron number are not equal. So we have more positives than negatives, or we have less positives than negatives. And then an isotope forms when we have an element with a different number of neutrons. Okay? All right. So let's go on to the second one, and I'll leave this up here. And again, remember that my notes are posted on Google Classroom. So if you're having trouble, they'll be up there. But let's look at this next one. Write this down if you don't have it. Remember that your atomic number is the number of protons. So Molly, how many protons do we have in that nucleus? How many positive charges? 2. Good. Then remember that the protons plus the neutrons is our mass number. So Molly, what's our protons plus our neutrons going to be? Very good. We're going to add the 2 protons plus the 1 neutron, and we're going to get 3. And then does anybody know the element's name? What is it, Cameron?
Helium.
It is helium. And how did you know it was helium? What number did you look at on the periodic table? So we looked at the atomic number. We looked at the 2. When we look at the periodic table, there's a 2 in the upper left-hand corner. That's the number of protons. That's the atomic number. That's what element it is. Okay? So for this one, is this atom an ion? Is it charged? Can anybody tell me? Jillian, what do you think? How many positives does it have?
2.
How many negatives does it have?
2.
So does it have a charge?
No.
No, it's neutral. So this atom is neutral. And if I were you, I would jot these down as we're going through them, because then you'll have a nice sheet to look back at. Okay, we did the next one together because I wanted to point out that it was an isotope. So I'll just quickly fill it in. So this next one has 1 proton, just like the first one. That's how we identify the element. So if the first one was hydrogen, then this one must be hydrogen too, because we've got that 1 proton. And if we look at the periodic table in the upper left-hand corner, that 1 tells us that it's hydrogen. But now the protons plus the neutrons, this one has 0 neutrons and only 1 proton. So its mass number is 1. So what is happening here is this element is hydrogen and so is this one, but they're isotopes of each other because they have different numbers of neutrons. This one has 1, 2, 3, 4, 5 neutrons, so its mass number is 6. This one has 0 neutrons, so its mass number is 1. So they are isotopes of each other, okay? Remember, when we're looking at the mass in the periodic table, this is the average weight of a hydrogen atom, but that can vary with different isotopes, and it's a weighted average. So they look at what isotopes are most common in nature. And so it looks like, because the mass is usually closest to 1, that this is the most common isotope. This one would be more rare. Okay? Brett? Yep. Okay, the next question. We're going to go through this one. Okay. How many protons, Natalie, for this one? What's the atomic number? Okay, so 1, 2, 3, 4, 5, 6. Yep. What is the mass number? The protons plus the neutrons. It is. So we've got 6 protons and 7 neutrons. So the mass number is going to be 13. What's the element name?
Carbon.
And how did you know? You're correct.
Because there's 6 protons, and I looked on the periodic table and it was carbon.
Very good. So there's 6 protons in that atom, and the 6 for the atomic number is carbon. Okay? So the average mass of a carbon atom is about 12 atomic mass units, but this looks like it's a little bit of a different isotope. It's got a 13 in terms of its mass number. So now, Alexis, how many protons are in this nucleus? How many positives? 6. So I'm going to draw that on the side. 1, 2, 3, 4, 5, 6. And Alexis, how many negatives? 1, 2, 3, 4, 5. Do you see that? So 5 negatives, and you guys should be copying this down. So 1, 2, 3, 4, 5. Now look, these are going to cancel each other out. This is an atom that, for one reason or another that we'll talk about later, lost an electron. So it has a positive 1 charge. So how we would write this is carbon plus 1. Okay, that's how we would write that. It's got a positive 1 charge. Now, if you remember with Mr. Wardell this year, when you did adding integers, you don't have to draw out the pluses and the minuses. You could just say a positive 6 plus a negative 5 equals a positive 1. Whatever way makes you feel more comfortable, the way you do it in math or by drawing out the charges. Either way will work. Okay, how about Claire, the next one? What's the atomic number?
4.
Because there's 4 protons. Good. What's the mass number?
8.
Okay, we do the protons plus the neutrons. So 1, 2, 3, 4, 5, 6, 7, 8. Good. So the average mass of this atom is about 8 atomic mass units. What's the element name?
Beryllium.
It's beryllium. Good job. That's a hard one to pronounce. Beryllium. And we know it's beryllium because if we look on our periodic table, the one with the 4 in the upper left-hand corner as the atomic number, okay, is beryllium. So Claire, help me really quickly. How many positives do we have?
4.
And how many negatives?
4.
So does this one have a charge?
No.
No, this is a neutral atom of beryllium. Okay? Luke, how about the next one? What's the atomic number?
4.
4. So we've got 4 is our atomic number. What is the mass number? That's your protons plus your neutrons.
12.
Okay, I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, you're right. So 12 AMUs, that's about what it weighs. What type of atom is this? What type of element? Remember to look at the atomic number. What's the atomic number? 4. So look in your element boxes. Which element has a 4 in there? Be, which is beryllium. Good. So look here. We have another atom that is the same as this one. So we have 2 types of beryllium, but the way they're different is they don't have the same atomic mass. So they're isotopes of each other. They have a different number of neutrons, okay? But like your last one, this has got 4 positives and 4 negatives, so it's not charged. Okay, Randy, do the next one for us. How many positives for this one?
10.
Okay, is that right, everybody? I didn't count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, good job. What is the atomic mass, which is your protons plus your neutrons?
14.
14. What is the element name?
Neon.
Neon. If you look on here, neon is the one that has 10 protons in its nucleus. You look at the atomic number. So that is neon. Very good. And then let's just see if this one is charged. What do you think, Alexis? How many protons does it have? 10. And how many electrons or negatives? 1, 2, 3, 4, 5, 6, 7. Okay. So what's the overall charge on this atom? What is it? 3. It's a positive 3. So how we would write this is like this. Now, I want you to keep in mind the person who wrote this worksheet, neon is actually what we call a noble gas. It's unreactive, it's inert, it would never be anything but neutral. But they must just be using this for examples. Okay? All right, the next one, how about Jordan? The atomic number for this atom is what? So 1, 2, 3, 4, 5, 6, 7. Good. And then what's the mass number? 11. Good. So what type of element is it? It's nitrogen. And we know that because if we look on the periodic table, we'll see that nitrogen has a 7 in that upper left-hand corner, okay? So that's what type of element it is. Then how many positives does it have, Jordan? 7. And how many negatives does it have? Look right here, kiddo. 7. So does it have a charge on it? No, it's neutral. Okay? Chris, how about the next one? What's the atomic number? What's the number of protons or positives?
7.
Okay. Is it 7 again? 1, 2, 3, 4, 5. Yep, very good. What is the number of, or what's the atomic mass, which is protons plus neutrons?
16.
You're just one off, I think.
17.
1, 2, 3, 4, 5, 6, 7, 8, and 7 is 15. So you were close. And then how many, what's the element name? Remember, you look at this.
I don't know.
Okay, look. When it was 7, it was this. So if it's 7, what does it have to be?
Same one.
Yeah, it's got to be the same one, which is nitrogen. Okay. And we've just got 2 different isotopes. They have a different number of neutrons. Okay. And how about Brooklyn? How many positives do we have? We have 7 positives. How many negatives?
13.
I think I counted 11. What'd you guys count?
11 or 13? Yes, 11.
It's 11. So what is that? A negative 11 and a positive 7. Who knows what that is? What is it, Alexis? Not negative 2. What is it, Gavin?
4?
Yeah, negative 4. And if you don't know, draw out the charges, okay? So then you would write this as N negative 4. That's how you would write that, okay? So again, we're just practicing this.